So let's talk this time about the period of a function. Remember that a normal sine function has a period between 0 and 2 pi, or in other words, one complete picture for sine occurs between 0 and 2 pi. So let's see what happens when we change this value right next to x. Okay, so if I change that, let's say I change that number to 3. Look what happened. This time, remember, a complete picture for sine starts on the x-axis, rises, goes back to the x-axis, falls, and comes back to the x-axis. So what do we have occurring here? We have one complete picture for sine occurring at some value much less than 2 pi. So we just horizontally scrunched this graph up, right? So in other words, my period, right, the time or the length that it will take for me to see one picture of sine is going to change. If I change that to a different value, let's make it bigger, or in other words, we changed this value. Now we took this, and I don't even get a whole picture in before I'm already at 2 pi. So in other words, this time I ended up stretching this thing horizontally. Okay, so for us in this class, for trig functions, anytime I squish or compress horizontally or maybe stretch horizontally, we're talking about the period and when I get to see the entire picture. So in the notes, we have that listed. Anytime we're talking about the period of our function, then we're going to be dealing with this number next to x. We call this b, okay, for our functions. Now, we take the b value and we replace the denominator of 2 pi over b with that number, and it gives me this new period, or the new value. So for a normal period, remember, if we just have y is equal to sine x, this would be a 1, wouldn't it? So if we have 2 pi over 1, the period is just 2 pi. Okay, and that's because I get the period by finding 2 pi over b. And that's consistent with the fact that we know that sine functions all have a period of 2 pi. Okay, so let's change that period and see what happens when we graph this one. So if this is my function, y is equal to the sine of 3x, I'm going to first start by writing some things down. Okay? First I have to figure out what the period is. So since the number next to x, the coefficient of x in this case, is is 3, then we know b is equal to 3, and therefore the period, which is 2 pi over b, becomes 2 pi over 3. So what is happening here? We have a new interval for my sine function that is occurring between 0 and 2 pi over 3. Since I'm changing my period, it's no longer between 0 and 2 pi, I've shrunk it, then I need to decide how my intervals are going to break up on my x-axis. And that's where we come into dividing this into 4 equal parts. But let me tell you, there's an easy way to do this, and you are going to become extremely familiar with your fraction button on your calculator. So the way that I do this is I draw 0 and 2 pi over 3. Remember, when we did this before, we want to find out, well, what's halfway between 0 and 2 pi over 3? So on my calculator, I'm going to treat 2 pi over 3 as 2/3. So I say 2/3. Halfway in between means I'm either going to divide by 2 or multiply by a half. So I'm going to multiply by a half times 1/2 on my calculator, surrounded by parentheses, math, frac, enter, enter, and it's going to return for me that halfway in between 0 and 2/3 is 1/3. So that means we're going to stick pi back on the top, and we have our middle of this interval. So let's take half again. Between 0 and pi over 3, what is halfway in between 0 and pi over 3? So I'm going to take half of pi over 3, or multiply by 1/2, times 1/2. Math, frac, enter, and you get 1/6. Okay, so this is pi over 6. Now what is this telling me so far? We have this extra blank, but what do I know? I know that each time I move on my intervals here, that I am going to be adding 1/6. So from 0 to 1/6 is, I'm adding 1/6. So I'm going to come back to 1/3, and I'm going to add 1/6 on my calculator. So I have 1/3, or pi over 3, plus 1/6. Or yes, plus 1/6. Math, frac, enter, and that's 1/2. Okay, pi over 2. Now maybe you can do these intervals in your head. Some of you can, some of you can't. It's not exactly the most fun thing to do, to add fractions when you don't have common denominators, so let your calculator do the work. Now, what does this tell us? Let me put that back. What does this tell us? This tells us that the x-axis on my graph is now going to be broken up like this. Okay, so we're going to graph my function using those new values. So I'm going from 0 to 2 pi over 3. So I just kind of make some distance up out here. I take half of that to be pi over 3. Half of that's pi over 6. And the other half is pi over 2. Okay? Our function is just the regular sine function 3x. In other words, the amplitude of this function is 1. So I need a 1 up here, a -1 down here, and because this is sine, I know I always start on the x-axis, go high, come back to the x-axis, go low, come back to the x-axis. That is the shape for my sine function. Now I'm going to connect the dots, and you can see that that's what it looks like. So for this particular example, we actually compressed the period, or the picture, of our sine function. Let's practice that one more time. Here we have the cosine function. We haven't graphed one of those yet, but we have a cosine function, and we can see that because there's some number next to the variable x, that I'm going to be changing the period. So the first thing I want to do is find the period. So in this case, b is equal to 1/2, and the period is always found by 2 pi over b, which would be 2 pi over 1/2. Okay, well, 2 pi divided by 1/2 or multiplied by 2 gives me 4 pi. So my new period is occurring between 0 and 4 pi. Boy, that one's going to be pretty easy to break up. My 4 parts occur between 0 and 4 pi. Halfway between 0 and 4 is 2 pi. Halfway between 0 and 2 pi is pi. And so therefore, if I'm incrementing by pi, then I'm going to add pi to this, and I get 3 pi. So these are the new values that I'm going to put on my x-axis when I draw this. So that's the third part, graph. So we come over here, we have our 0 to 4 pi, we have halfway at 2 pi, half of that's pi, the other half is 3 pi. The amplitude for cosine is still just 1, so I only need to come down to my graph and add a 1 here and a -1 here. Now we haven't graphed cosine like I said, but all cosines are going to start high, cross the axis, go low, cross the axis, and end high. All cosine functions do that. So we can connect the dots and sketch the graph. And you can see how this period is actually stretched. Okay? And that's how you would graph the period for sine and cosine.